Hello, thank you for watching this video. So on this video, we're doing question 2 of November 2021 question paper Physical Sciences paper 1. These are forces or Newton laws or laws of motion. I don't know how to call this topic, but let's go. So question 2 reads as follows. A 20 kg block is placed on a rough surface inclined at 30 degrees to the horizontal. A constant force F acting parallel to the surface is applied on the block so that the block moves up the incline at a constant velocity of 2 meters per second. Refer to the diagram below. They are also telling us that a constant frictional force of 18 Newton acts on the block. Okay, so now you have this 20 kg block that is placed at this surface here, which is 30 degrees with the horizontal. This is the inclined surface. It's inclined at 30 degrees, right? So this force, which is parallel to the slope, is applied on this 20 kg block so that it goes up the slope at a constant velocity. So let's go. They are also telling you that there's also a kinetic friction acting on this block of 18 newtons. It acts on this block. So what are they saying? 2.1, state Newton's first law in words. They wanted to state Newton's first law in words. I'm not sure if I should write that down. But Newton's first law states that an object at rest will remain at rest, and an object in motion will remain in motion at a constant velocity or at a constant speed in a straight line unless an unbalanced force acts on the object. Right? So I'll repeat that again so that I don't have to write it, or maybe I'll write it down if you want me to. An object at rest will remain at rest, and an object in motion will preserve its motion at a constant speed in a straight line unless an unbalanced force acts on it. That's what Newton 2 says. I'm not sure if I have to write that down. I don't think so. So I'll just say stated. Done. We move. 2.2. They are saying, draw a label free body diagram for the block. So they want you to draw a free body diagram for this 20 kg block. That is your 2.2. How do we do this? We say, okay, let me use another color. I'm going to use the red color. So here is your block here. We have a force applied, which is up the slope, which is F. You are told that you have kinetic frictional force. It's down the slope, Fk. Because force applied, there is it. You have kinetic frictional force which opposes the motion. Right? So here is it. So, because the object is sitting on the surface is pushing the object. It's applying the force perpendicular to the object, the normal force, which is this. So if you're drawing a free body diagram of an object that is placed on a surface, you will always have this force here, this normal force. It will always be perpendicular to the surface. So it's a force of the surface on the object and it's perpendicular to the surface. It's normal force. What else? Other force that we have is gravitational force, Fg. Here is a free body diagram. Even though this free body diagram is nice and correct, I don't like it much, because sometimes you miss the most important things because of this free body diagram if you're not very familiar with it. Because this object is on the slope, right? You can see that because this object is on this slope like this here, so the gravity, you can also break it into two components, right? So if I draw it, I can draw it like this. It's the same free body diagram. Also, okay, it's my applied force. Let's just say, okay, force applied. What else? It's your kinetic friction. It's your normal force. The only thing that you change, or maybe that you will look different, it's just that instead of drawing this gravitational force here, we'll draw its components. One will would be perpendicular to the surface and the other will be parallel to the surface. So you draw these two forces there. So one will be perpendicular to the surface and the other will be parallel to the surface. So both free body diagrams are correct here. So I'll choose this one over that one. I know many teachers like this one, but it does not help me much when I do the calculations because sometimes I can forget those components and only work with those two and then forget the third one. So yeah. Now we move to 2.3. They're saying calculate the magnitude of force F. So they want us to find the magnitude of force F. Right? No problem. To do this, we use Newton's second law of motion. Right? We use Newton. We'll use Newton 2, which is F net is equal to ma. We know this, right? So what is F net? F net is sum of two or more forces acting on an object. So in this case, the force of interest, we want this force here. So we'll only deal with forces that are parallel to the slope, not these ones that are perpendicular to the slope. Because the force that we want is parallel to the slope, only use the ones that are parallel to the slope, not the ones that are perpendicular to the slope. Even if you can use them, they'll cancel out anyway, but use the parallel ones to the slope. So F net, and the box is going up the slope. Take up all the forces going up the slope as positive. Right? It's more like you have some sort of a coordinate system like this. If it's going to the right, it's positive. If it's going up, it's positive. So all forces going to up the slope are positive, and all forces going down slope are negative. So let's add our forces. Force number 1 is F plus force number 2, which is frictional force, but it's negative because the kinetic friction because it's going down slope, plus Fg parallel is negative as well because it's going down slope, is equal to ma. So we know that F minus Fk, we know Fk because we're given Fk to be 18 newtons, minus Fg parallel. Fg parallel is calculated as mg sine theta is equal to ma. So we know this. We know the mass, we know gravitational acceleration, we also know our angle as well. We have the mass. What we don't have is the acceleration. Right? We're not given anything about it. We're not told what the acceleration is. But we're told that the velocity is constant. What does this thing mean? If the velocity is constant, it means that, what does it mean for velocity to be constant? It means that there is no acceleration. Which means your acceleration is equal to 0 meters per second per second. Because acceleration is the rate of change in velocity. In simple terms, it measures how much velocity changes per second. But our velocity is constant, so it does not change per second. So the change is 0 because it's final velocity, which is 2. Because we're told that the velocity is constant at 2 meters per second, right? So if you want the change in velocity or the rate of change in velocity, you will say my acceleration is equal to v final minus v initial all over change in time. But v final is equal to v initial because v is constant, so it does not change. Therefore, your acceleration is equal to v final minus v final, or your v initial minus v initial, which is equal to delta t. So this is equal to 0 meters per second per second. So the acceleration does not change here, because acceleration again is the measure of change in velocity per second, but our velocity is not changing, so there's no measure in change in velocity, it's 0. So we know our acceleration is what? 0. So which means we know everything here. So we can find the force that we want. Every time when you're told that your velocity is constant, know that your acceleration is 0 meters per second. Oh, no, when you're told that your velocity is constant, know that your acceleration is 0 meters per second. Your net force is 0 newtons and your work net is 0 joules. That's what you need to know. Let me repeat this again. If you're told that the velocity is constant, know that the acceleration is 0 meters per second. The net force is 0 newtons and the work net is 0 joules. That's what you need to keep in mind all the time. You will not be told that information step by step, but you should know, should infer it from this. So, now we can continue. So our F minus Fk. Our Fk, we're told that our kinetic friction is 18 newtons minus mg, which is 20, times g, which is gravitational acceleration, 9.8. Sine what? Sine 30 degrees is equal to 0. Because you have your acceleration is 0. So if you want, you can say your MA if you want. You can M is 20 times 0. Because you know acceleration is 0 because the velocity is constant. So you can solve for your friction, your F there. Punch this on the side. So we have negative 18 minus 20 times 9.8 times sine 30. We get that F minus 116 is equal to 0. Therefore, your force applied, the F is equal to 116 newtons. So this is your magnitude of your force applied. No problem. So we move. They are saying now the force F is removed when the block reaches point X on the surface. The block continues to move up the slope and comes to rest momentarily at point Y. Let me read this thing again. They are saying force F is removed when the block reaches point X on the surface. The block continues to move up the slope and comes to rest momentarily at point Y. Assume that the kinetic frictional force acting on the block remains at 18 newtons as it moves from point X to point Y. So, what they're telling us is that when the block got here, at point X here, at this point, the applied force was removed. So there was no applied force when the block was here. But it still continued up the slope. But because it was moving at a constant velocity, you know that it arrived at a velocity of 2 meters per second. Since this was the velocity at point X, it was 2 meters per second. No problem. So they're saying that assume that the kinetic frictional force is the same. So once we get to this point here, point X, and the frictional force, the applied force is removed, which means on this flipboard diagram, we don't have an applied force anymore. This is all we have. We just have these forces. There is no applied force. So this box will move from here to point X from the initial kinetic energy it will have from this point. It will continue from X to Y due to its initial kinetic energy when it arrives to point X. No problem. So that's saying write down the net force acting on the block as it moves from point X to point Y. So they want us to write down the net force of this block as it moves from point X to point Y. But look at this flipboard diagram here. You can see that 2.4, we're doing 2.4. So what they're looking for, just to be clear, they want the kinetic in the net force where the block is moving, when it moves from point X to point Y. They want that net force, right? So what do? We say, okay, we're going to find the net force of the new thing now, of the new system. So what do we say? Say F net is equal to what? The sum of forces. So it's negative Fk plus negative Fg parallel. So which is what? Negative Fk plus Fg parallel. So this, if you look at this, you'll see it's exactly this part here, or this part over there. It's exactly, these two are exactly these two things that you added here. It's exactly the same stuff. So it's easy to see that the F net should be equal to this one, but in opposite direction. So it should be negative 116 newtons. That should be a net force. Because the new net force, it will just be these two guys. And you can, this is minus 18, and you can find this because mg, here is it, it's mg sine theta. So if you don't understand this, so you can find it and say, okay, my F net is equal to negative Fk, which we're given because it's 18 minus mg sine theta. This is your net force. You're done. Should be that. So I'll clean the board. Okay, so now we'll do 2.5. They are saying calculate the distance between point X and point Y. So they want us to calculate the distance between point X and point Y. We know that at point Y, the final velocity is 0. Its initial velocity was 2 meters per second because that's the velocity it arrived with from that constant velocity there, which we're given is 2 meters per second. So here, we know the final velocity is what? Is 0. So we can find the acceleration between these 2 points. So you can say that F net is equal to ma. We know what F net is. Our new F net is minus 116 equal to 20 times your acceleration. Divided by 20, divided by 20. What is the acceleration? The acceleration is equal to negative. The answer of that. Let me patch that. Minus 116 divided by 20. So you get that the acceleration is minus 5.8. This is your acceleration. No problem, right? So meters per second. It should be units, of course. Then now, but we want the displacement, right? Between X and Y. That's what we're looking for. So we say now Vf squared is equal to Vi squared plus 2a delta x. This is the equation of motion. You have the final velocity, you have the initial velocity, you have the acceleration. You need the displacement, right? So what is your final velocity? Is 0 squared. What is your initial velocity? It was 2 meters per second. Plus 2 into negative 5.8 times delta something, right? So you solve for this thing. So get that 0 is equal to 4 minus 11.6 delta x. This is the displacement. Then transpose one of the two. 11.6 delta x is equal to 4. That's what we have. So you divide by 11.6 both sides. What do you find? If you divide by 11.6 both sides, find that your delta x is equal to 4 divided by 11.6. You get that your displacement is 0.5. 34 meters. Here we go. We should be done. Because from here you transpose this to the right and divide both sides by 11.6 so that you are left with the delta x. There is your final answer. And with that we should be done. I hope it does make sense to me as it does to whoever that is watching it. If you like the video, please let us know in the comment section. Like and subscribe to our channel for similar content. We hope to see you very soon. Cheers.